I got about the first 5 minutes because they kept switching between English and math, and I just couldn't do that. I mean, I had to stay within the math all the time, please. And so it was a very hard on me, but it turned out to be incredibly useful in terms of making an impact in real life.
Welcome, Susan, to the Journeys of Scholars.
Thank you. It's a pleasure.
It's really a pleasure having you on the show. So, Susan, as you know, academia is a perfect place to sharpen our research abilities towards excellence. However, it might be less helpful about mentoring us and managing our wider context, life in general. So this talk is about gaining a bit more insight about how scholars that are further down the path can help us understand, how to manage those parameters.
Yeah.
So, Susan, you are the Professor of Statistics and Computer Science and the Radcliffe Alumnae Professor at Radcliffe Institute at Harvard. You are the lead of the Statistical Reinforcement Learning Lab, and the lab has two key objectives, which has to research adaptive interventions, and secondly, to develop algorithms for just-in-time adaptive interventions. And so you have been, through this research, honored by several committee memberships, such as the National Academy of Medicine, National Academy of Sciences, and also several honors, the Leo Breiman Senior Award in 2022, Royal Statistical Society Guy Medal and Silver Medal 2019, and not least the MacArthur Fellowship in 2014. You're also the former editor of the Annals of Statistics. So, Susan, looking at your professional life, and also it's in your very title as a professor, which is that you're both in statistics and computer science. And so, revisiting Leo Breiman's article that I've myself written quite some about, the statistical modeling the two cultures, where he roughly speaks about these two ways of thinking about data, right? The data modeling culture, which is much more sort of situated in statistics, where you postulate models, you test them, and you evaluate how valid they are based on data. And then you have the algorithmic modeling culture, which is much more suited to the computer science way of thinking, which is that you develop algorithms that adapt to the data. So you sort of get these black box models, but they're hugely adaptive and also very strong in terms of discovering structure. So how do you merge these two cultures, these two worlds in your research, practically speaking? How do you bring about insights from both of these disciplines?
Well, it's now some time since Leo Breiman made those statements. And in fact, I would say that the CS community and the stat community have both moved towards the center of that divide. So I don't see that strong of a divide. Like, I have colleagues who are mainly doing model-based reinforcement learning. And some of them are involved in robotics, and they're using very strong mechanistic models, better models that you and I could make that can, because you and I work in the social and behavioral sciences, and it's much harder to come up with a really high quality mechanistic model because our fields are frontier fields. Exactly. Whereas in robotics, you have a better chance of coming up with mechanistic, really doing modeling and fitting. And I have a number of colleagues that actually are doing that. So I don't experience that divide as strongly, I think, as I would have even a decade ago. So I think the divide is really diminished. That said, for example, in reinforcement learning, this is a field, it comes out of cognitive neuroscience, psychology, and out of CS. And a lot of people in CS go back and forth between cognitive neuroscience and CS in terms of sequential decision making. And that is a field that there has not been a lot of thought about statistical reasoning with bias variance. However, even that is changing very rapidly in the CS community, very rapidly. But we statisticians have a lot to offer to that field.
And so you see that sort of learning between the cultures. I mean, so statisticians are embracing more and more of the machine learning algorithms and vice versa, basically, right?
Yeah, I don't really see that divide like I used to. I mean, many statisticians, many, not all, but many statisticians have a more theoretical bent. And so they, in fact, are very similar to the more theoretical computer scientists, like theory of deep learning, that sort of thing.
Yeah.
So that's not, there we really intersect very strongly. And when you get to more applied statistics, there are people who are in CS who are very interested, for example, in sequential decision making and are doing model-based type work.
Right. So I'm thinking about causal inference, for example, where we have often, that's sort of a hypothesis testing type of, not exactly that, but it's sort of you have a structure or kind of a, maybe a directed cyclical graph, or at least some story that you want to identify a parameter. That sort of resembles the data modeling culture to some extent, but then obviously now you have like the latest, 5, 6, 7 years, more machine learning powered estimation method. So you're right in that sense that there's more and more of a mixture.
Yeah.
Exactly. So how much, in your path, Susan, when you, I mean, you started off in mathematics. Your love for mathematics is not a secret. And so how come that you chose statistics and later on computer science, opposed to say a pure mathematician path?
Yeah. So I started thinking about this I guess like right after tenure. I look to the leaders of our field, people whom I admire greatly. For example, Brad Efron, David Cox, who now has left us. These people both contribute to theory, but they really have their feet on the ground. In other words, they're pursuing theory that's strongly motivated by an application. They're not just solving a beautiful problem. They're trying to solve a beautiful, relevant problem. And I thought to myself, well, I want to try and pursue a life that's more similar to theirs. And that's when I really started, at that time, I really started to get involved with the behavioral and social sciences. And that was the causal inference and sequential decision-making side.
And this is about, so I know that you were the a research professor at the Institute for Social Research at University of Michigan. This is 2001 approximately, and then for about 15 years or so you stayed there.
Right.
So, walk us through that like movement from, BA in mathematics and then, PhD.
Yeah. So I love martingale theory. I like probability. It's so beautiful. But again, I wanted to, follow in the paths of these individuals. I saw how they make an enormous impact in their life. And so I began going, this was when I was still at Penn State, and I began going to these brainstorming sessions with behavioral scientists. And it was very stressful for me. I mean, I only understood like 10 minutes of what these people said. I mean, all their English, English. I couldn't understand. And so then when I got the opportunity to join the statistics department at Michigan, I was also able to get this opportunity to be part of the Institute for Social Research. And at that time, some very prominent social scientists were there. Ushia in sociology, Steve Roundbush in education. And we formed a team, and it was great for me. Again, we ran these brainstorming sessions. And I think about the first year, I got about the first 5 minutes because they kept switching between English and math, and I just couldn't do that. I mean, I had to stay within the math all the time, please. And so it was a very hard on me, but it turned out to be incredibly useful in terms of making an impact in real life. So those guys trained me up. And it was Linda Collins at Penn State, and then following that, Steve Roundbush and Ushia. Right. I owe them a great deal. I learned a great deal from
That's
them.
fantastic. We have actually Stephen Radbush on the show as well. We interviewed him
That's
a couple of
great.
times ago. So you should definitely listen to that interview as well. So what did you learn? Like what was the thing that you like that stayed with you?
I think the thing that stayed with me is at that level. So we're talking about an extremely high level, right? Both you, Shia, and Steve Roundbush. This is a very high level of communication. So in they're communicating using English with great precision, and
That's what you mean by high level, like it's abstract.
you would think, I
Nice.
mean, it's much harder to communicate in English with precision as compared to mathematics with precision. And um, part of that is to understand the context in which these words are being spoken, the form of the sentence, understanding the area that they're alluding to. And it's very easy as a straight up statistician. Certainly, I had colleagues that were like this, and I myself was like this. I'd listen to them at first, and I would think, well, I understand every single word they put together in that sentence. And I would think I really knew what they were saying, but in reality, I hadn't the faintest clue.
Right.
And you see this a lot, actually. This is a big problem, as you know, in interdisciplinary work, that each discipline looks at the work and can only see a third of the work, third of the contribution. And what they taught me to do was to be able to see not only the contribution by the more probability or more statistical theory, but also see the contribution coming in from the behavioral science or the social science. Right. And to understand the level of precision it takes in communicating complex ideas is not trivial. So now I'm much better able, like I have been involved in papers in which we were communicating for a behavioral science audience, and I realized the difficulty of this. I mean, it's not just stringing together words that seem relatively simple. There's layers and layers. At that very high level, there's layers and layers of meaning, and you need to communicate with those layers of meaning. That's the expectation.
Right.
And if you want to achieve any, yeah.
I mean, that's so resonates with my experience as a social scientist. Been trained in social science and then going into more stats, which is that you have to, you're used to communicating in that way that you're describing, but then you also now have to learn the language of like translating to mathematics. And so is there, I mean, this might be, this might be a topic in its own right, which is that, is English enough to capture that level of precision? And I'm not saying that we should use math. Maybe there's like a bridge language that needs to be developed, which is between the math and between the English, but is adapted to these complex systems, which is what social life is about and health in general.
I think statistics is that bridge, in my opinion. But it's not trivial to do it. It requires a great deal of thought, because you can give it, even a top-notch social scientist, behavioral scientist can frame a question in a certain way, and then you can mathematize that question in multiple ways. I mean, we've seen this with massive controversies in the causal inference field, where people are using the same English but mathematizing that English very differently, and they argue with each other. And in fact, they're answering totally different questions, and they haven't back. To me, the tool, the technique I think that's most useful is you attempt to using statistics and mathematics. You attempt to mathematize an English goal, a goal that's stated in English, and then you look at the math and you try and state it back in English. And you have this iterative process where you arrive at, well, what did we really want to answer here?
Right.
And that helps both sides. It certainly helps me, and it helps my collaborators. And often I'm mentoring either a young behavioral scientist or a young statistician or a computer scientist, engineer, and it helps that person start to see that back and forth translation, because we go back and forth.
Yeah, exactly. I mean, one thing that I wish we did more maybe in the social science training is to go a little deeper about these basic concepts in statistics, which has, just like what's a random variable. I mean, right? I mean, Joe Blitzstein has that you've taught with at Harvard. He has this great course, Stat 110, which goes deep down in those definitions. And one of the things that hit me was that random variables, it's sort of a deterministic function between the event space and the sample space and the real line, and then you have a distribution over it. It's like, what? It's a deterministic function? I thought it was random. But those things help at least me and my collaborators to be a bit more flexible about what this random variable could be, right? And try to maybe conceptualize it's in a different way or adapt it to a way that aligns with maybe some English concept that has yet to be sort of formalized.
Right.
And so how much of that, during the Institute for Social Research, like how much of that and through the lab and the teaching that you do you engage in these sort of very fundamental conceptual, exercises?
I think this is my primary role, because I am managing a lab, right? So I have electrical engineers in this lab. I have computer science students. I have statistical students, statistical postdocs, biostat postdocs. And we're engaged in putting real online algorithms into trials that run in trials. So these are big collaborative endeavors. So I think the vast majority of my time is doing exactly what you say, trying to figure out exactly what is the fundamental problem here? How do I match the math of the algorithm or the math of the learning? So I call it learning. It's really incremental statistical procedures, methods. How do I match the math of that to the actual problem, the domain problem? And the students and the postdocs, they go through this. We go through this iterative process. I mean, of course, it's very hard. Some people don't resonate with that. But in order to get the buy-in to actually be able to run an online algorithm, it's operating, on someone's phone or in the cloud, to get that kind of buy-in with a domain scientist, that's not trivial. They have to, they're depending on you for they're dedicating like 5 to 10 years of their life to the idea and if you mess up, you can really harm their science. So the amount of trust and mutual respect that's required is massive. And that's one of the things I really, and this is all related to this high level communication. Because if you can't communicate at that high level, they can't read my math. They haven't the faintest idea how good I can do math, right? They're going to judge me by how well I can communicate, how well we come through, how well we make we protect their science and enhance their science at the same time we're enhancing our science.
So what's your number one tip for managing a team like that? What, like, if you like a checklist or
it's hard. This is where I learn a lot from my CS colleagues, because many of them manage labs. And that's the advantage of having a lab in the engineering school, is because it's a very lab-based environment. And I need, I'm a statistician. I never got it. I have no idea, I didn't have any training in this area, right? And so there's a lot of things I do. I learned this both from behavioral scientists who manage labs as well as computer scientists that manage labs. But how to set expectations, how to help people brainstorm about ideas and not be worried that someone else is going to steal their idea. These are all really important. How to have a respectful culture within a lab. The problem as a statistician like me is the price I pay. The big gain is, I have online algorithms in real trials running. Right? That's the gain. That's a big gain. But the price I pay is I have to really structure my time so that I reserve time. For example, normally it's every morning. I have this structured time where it's completely reserved, where I can read papers, I can think more deeply about a problem. And if I'm not careful, I'll lose that time.
Oh, yeah,
And
yeah.
that's the price of running a lab, is
Right.
you can accidentally lose your deep thinking time.
Mm-hmm. That's so important, because one of my critical questions that I tend to ask are, and people coming on the show, is exactly that. It's like, how do you, as you progress in your career, reserve a slot for deep work, deep thinking,
Yeah.
which you see that diminish as you progress
Yeah.
through the ladder of academia. It's sort of a paradox of success, if you like.
Yeah.
Which is that, the more successful you get, the thing that you're successful, you're doing less of it as you progress forward. And so how do you talk us through a little bit, Susan, what do you do how do you manage that? I mean, we have several layers of question now, which is your time as a lab leader and for the deep work, but also building the lab culture, which requires its own structure in terms of, practically arranging time and, creating that, what you just said, which is so important, to create that space where people feel trust towards you and the lab members, where ideas flow freely and constructively critiquing ideas to develop them, and people don't feel like, oh, my idea is going to be stolen. So let's try to disentangle these two layers.
Yeah. So every fall, we have we have a lab session every week. Everybody in the lab meets, and in the fall, the first lab session of the fall, we have a whole lab session about brainstorming and the purpose of brainstorming, and how whoever is leading the brainstorming owns all ideas that are voiced during that period. All the ideas that get voiced they're freely given to that person.
Oh, fantastic.
They're a gift to that person.
Oh, fantastic.
Yeah, and that person can choose, of course, to potentially end up collaborating with someone, but that's their decision. That's not your decision. The other thing, which is, I don't know, this is more uncomfortable, is, and this happens routinely in CS labs. People don't even think about it. Is that all the students, the postdocs, they have to, whenever they want to start a collaboration, they have to consult with me. And this sounds, if you're a statistician like me, to my ears, this sounds appalling. To tell me that I have to go and collaborate with my lab lead, I mean, I have to go and tell my PhD advisor or my mentor, my PhD mentor, my postdoc mentor, that every single collaborator, but the reason why they have to do that is to prevent the perception of ideas being stolen.
Oh, I see. Okay, I see.
It's absolutely critical that I manage that. Otherwise, we can't have a free brainstorming. We can't freely brainstorm, because and this is really common. It's not only you have statisticians, engineers, and computer scientists, and often we have behavioral scientists at these meetings. It's not just that you have different disciplines. You have people with very different ethnic, cultural backgrounds.
Right.
And if you're from one area of the world where data needs to be free and fly away, and you're from another area of the world where data has to be held closely to the chest at all costs because of the price that you paid to collect that data, these cultures, they clash. And so things have to be more overt than it's not pleasant for me, but I do it anyway. I mean, it's essential we do it, right?
So just to clarify, so basically the postdoc or the students, they come to you to talk through the idea and basically, just vent it. Can we do this? But it doesn't necessarily mean that you'll be involved in the paper. It's just a way of checking. You might be, what might likely be, but
I might not be. If I'm not interested, like we have some of the postdocs right now are submitting a paper to NeurIPS, which is the deadline's really soon. Yeah. And one of their papers, and I'm not, it's just that area is just a little too tangential to my interest. So I'm not even involved. So that's okay. It's just keeping me in the loop so I can make sure that no one is accidentally stepping on someone else's toes.
Right. And so how do you manage that particular uncomfortable principle, because it is sort of uncomfortable in the sense that like you're sort of imposing a principle. It looks like it. I mean, the reason is very good why you're doing that. But it's just like this sort of academic freedom clashes with the fact that we are sort of working in a lab. But we are simultaneously, academic freedom is just one principle among several principles that we have in academia. So it's not necessarily that, you know, that principle should have the leeway, right? So how as a lab leader, how do you manage that principle? If you see what happens, like if someone doesn't, you know, accidentally or, you know, just like, oh.
Yeah, we have a discussion. It's not good. It's never good. But the people in engineering and CS, this is the world they've grown up in. So they buy into that real fast.
Oh, okay.
It's so really more the statisticians that struggle. People like me.
Yeah, and like social scientists, the competition.
Research. Yeah, but the behavioral scientists are also lab-based. So this is consistent with the way they've grown up. So the people that struggle most are people like me. You know, people coming out of statistics.
Right.
And they struggle more with this because we come out of math originally, and math is a very individualistic field.
Right.
And sociology is probably less individualistic, but it still has some elements of a more individualistic.
Yeah, field. Yeah, totally. And so okay, I see. And so this is right. So it sounds like more managing our own emotional tension rather than necessarily if it's a CS person. But this, so what kind of a pushback would you get, and how would you handle the pushback?
I don't do very well. I just say you can't work on that topic because blah 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 is working on that, and we have to be good colleagues. And then I'll often suggest an area that's related but different, and that often helps. That tends to be very helpful, because often when someone comes to me, they're coming to me earlier, and so the idea they have is relatively vague. So it's at a good time where they can move it a little to the left or to the right, and not step on their colleagues' toes.
Right, I see.
So as long as people come to me really early, it's not a big deal. And I haven't right now. I mean, I have problems with people, you know, being employed, you know, accepting NIH funds for research and then working on problems that I don't know about on totally different topics. And that's a big problem, particularly for statisticians, because we are individualistic. I mean, I'm just like them. So I get what you know, that's a big problem. So that's something I have to manage, but that's totally different. Then you're not stepping on anybody's toes. Instead, you're being funded to do one work and you're doing something totally different. That's a different kind of ethical consideration.
Right. It sort of comes with the fact that, you know, you wrote the grant 2 years ago, but now you have better ideas, but you got the grant 2 years ago.
No, that's totally different. Now it's where you work on something that has nothing. Zip.
Oh, okay. I see. Like so. Okay.
Zip. And you don't tell anybody. So that's a problem. And that's a problem we always, and I'm just like that. I come from that world. That's me. So it's like I'm talking to me. I'm talking to younger me's. On the other side, like more on the CS side, a big problem that we confront, and this is with postdocs as well, is that data must be free. And, you know, the behavioral scientists, they may have sacrificed 5 years of their life or 8 years of their life to collect that data, very novel data. You can't, you know, so we in the lab, we can't go and start sharing it willy-nilly. You know, and first of all, people had to be consented to allow that data to be shared. And these are very difficult concepts on the CS side, because they're less used to that, whereas statisticians pretty much get that right off the bat. You understand? So it's not like any one field has the game under control, right?
Right. And so
none of us have the game under control.
I mean, we're a captain of a ship in a very, you know, dark waters. Like it's like windy. It's very, you know, everywhere.
And you want to go in a certain direction.
Exactly. But the compass is not working very well. You're not seeing the
Yeah.
stars
Yeah, you
fully.
just do the best you can. Everybody, as long as everybody has goodwill, I
Yeah.
think we do fine. We're just
Right.
all trying. Yeah.
Yeah. Yeah. And so the question of your own deep work in this domain of managing a team, which is, I must say, this is something I'm myself thinking a lot about as we sort of now I'm progressing into a lab leader position. And
Yeah.
how do you like walk us through the process of you starting a lab, you today, in terms of what you just said about creating that slot, and how
Yeah.
large is that slot?
Yeah, it was very large when I was at Michigan. I had research scientists, people who had research positions that had PhDs. They weren't postdocs. So at
Mm.
Michigan, I had a very large lab. At Harvard, it's a smaller lab, but it's still pretty large. Maybe I think we have 6 postdocs right now
Mm.
and
Mm.
maybe 6 PhD students.
Yeah,
But I
that's.
don't have research scientists anymore.
Oh, I see. Okay. And the Michigan lab was how large?
It was about the same, but I had 2 research scientists, and these
Oh,
people,
yeah.
they go through a tenure process, but it's a very different tenure process because no one's looking at their ed. They're not teaching, right?
I
It's
see.
a different
I
kind of
see.
tenure process. But their tenure is more related to funding, obtaining funding, and research productivity.
I see.
Whereas in our tenure process, the one you and I would go through is
Mm.
research productivity and teaching excellence. Theirs is funding and research productivity. Anyway, but when you have research scientists, they help you a lot with the mentoring, so you have a little bit more time.
I see.
Um,
I see.
and I don't have, yeah, so that's a price you pay when you don't have research scientists.
Yeah,
Because
and,
you're
and and this is a matter of funding, Susan, or like how did two University of Michigan and Harvard work differently in terms of research
Yeah,
scientists?
it's just different. They have different advantages and disadvantages. There's some real great advantages here, and there's other things that are slightly harder to do. So every time you change universities, you trade. No matter what we think in our head,
Mm.
we always think the grass is greener on the other side, but it's green on both sides. It's just green in different ways.
That's a nice way of putting
and
it.
and you just find, so whatever like right now, for me at Harvard it's great because I really need to be around these computer scientists. They stress me out to no end because I'm so ignorant, but this is the direction I needed to grow in
Mm.
order to achieve the goals I want to achieve. Whereas at Michigan, I really needed to be around the behavioral scientists and the social scientists.
Mm. Mm. I see. Oh, that's so interesting. And so most of the people in your lab, the PhDs and the postdocs, are funded by projects, not by Harvard or like,
Oh yeah, yeah, it's all funding.
all
So
funding, all funding. Okay.
it's either like NSF funding or NSF, National Science Foundation. NIH is National Institutes of Health. A lot of it's National Institutes of Health.
Mm.
We do get some gifts from industry
Mm. I
that
see.
will fund some work. And then students also apply for, like
Mm.
I have 2 students with NSF
Mm.
pre-doc fellowships.
I see.
Uh, and that's great. They have that gives them really independence, a lot more independence.
Right. So okay, I see. So, right. And the
But
PhDs
even when, but
take
even
the,
when they have, like
yeah.
these 2 students that have NSF pre-doc fellowships, they're both CS students, and they're heavily involved in the actual real life implementation. So,
Mm.
if they're interested in real life, they're going to be interested in real life regardless of whether their funding is wherever their funding comes from.
I see. I see. And some of these students would be going, I mean, they will also be funded by these projects, or they go through the Harvard graduate student program. So they funded by Harvard.
No, at Harvard, so your first year as a grad student is funded
Mm.
in any department. I mean, it's
Yeah.
funded, period. And then after that, depending on the school you're in,
Mm.
you're funded by differing means. So,
Mm.
like in CS, in computer science, the funding is primarily grants, funding by the invest or industry funding.
Yeah.
In statistics, it's a mixture of grants, as well as there's the opportunity, because statistics, as you know, is an extremely high demand field. I mean, there's so many undergrads that want to learn statistics. I mean, it's just such a high demand field that we have a lot of demand for teaching fellows. So a student can say, well, I would rather, like right now I have a student who I asked, would you like to be on a grant? And she's deciding, well, maybe she'd prefer the more work teaching, because that builds her resume up in that direction. So students have differing, it depends on how they're trying to build their resume at each time. They may want more evidence that they're an excellent teacher. It just depends on the student. It's really student dependent. In statistics, there's a little bit more. Actually, both fields, the students can make those decisions. Do they want to spend more time demonstrating excellence in teaching versus demonstrating excellence in like implementation or research that's impactful in some way near time? Yeah.
And so in terms of mentoring, and this goes back to the question of creating deep work, the deep work for Susan so that she can continue the writing and maybe the coding as well. I'm not sure how much coding you do nowadays compared to back in the days.
I don't do any coding. I used to code a lot, but I don't code now at all.
You miss it, I guess.
I don't really. I mean, all of my students have to code in Python, and and I never learned Python, right? I mean, it wouldn't have been something I learned. I don't really, I miss what I really, to be honest, if I was going to miss anything, it's doing mathematical proofs, that I would, and I still spend time on that. So I miss that enough to, I'm having to fix proofs, stuff like that.
That's good. I mean, it's important to have, a piece of a candy for intellectual curiosity. And so for the writing part, so when you do this, the deep work, and this, like, it's mainly for reading your students and postdocs work, or is it just widely reading? Do you do writing in these slots, or what's like, how much writing do you actually lead nowadays?
I do a lot of writing, but I don't like to write. I mean, I'm a really typical statistician. It's hard. It's very stressful for me, and it's hard on me. So I do it, but it's not, I do it because I have to do it to get where I want to go. It's not a pleasure.
Okay.
Whereas it's a pleasure to, like if I'm thinking about right now, I'm thinking about these problems where you have social networks and there's a target person in the social network, and you're trying to develop an online statistical algorithm that'll provide support for both the individual, the target person, as well as moving their social network to a more supportive place for that person. These types of issues come up in cancer and in addictions and in mental illness all the time. Anyway, and so I spend a lot of my time reading in across the fields of control engineering, statistics with business applications for sending nudges, and reinforcement learning, and going through the math there to think about how to develop this method so that it learns quickly enough on people. And so the deep thinking is more about how to really connect the domain science, how to mathematize the domain science problem well enough so that you're capturing the underlying essence of the problem. Because, the math can never, it's always a toy version of the real life problem, right? So you have to figure out what aspects of the problem do you have to really capture. And for me to do that, I have to read across all these disparate fields.
And that's what mainly you're doing when you have a free slot. Well, you create a free slot, the deep work slot.
It's a brainstorming. It's self-brainstorming, because I have some, like we already have the funding and everything. We're going to actually run an algorithm in one of these social networks with a target person, and our lab's got to be ready. It's going to happen next year, a year from now. And I got to have a good method. I got to understand enough Bayesian statistics. I need to bring these ideas from reinforcement learning, from control, causal, this is all causal modeling as well. I have to bring those together and produce an algorithm that can learn online. I mean, and how do I warm start this algorithm? You know, all of this, I got to get my act together, because I know next year we're going to go in the field, and we got to be ready. You know what I mean? We can't just throw up our hands and say, you know, right, it's not gonna happen.
And so when you develop these ideas, Susan, I mean, it's to say that you have like a really gold idea. What's the process of well, first of all, the process of distilling gold through, you know, like you read and you take notes, I guess, like on paper, you do stuff, and then what do you do with that gold idea? You say like, oh, hey, my postdoc, let's work on this, or students, let's gather around this idea, or you try to chop up the gold so that you can basically run on different directions. Walk us through.
You know, in terms of trying to provide ideas for students, it is definitely chopping up the goals. So that's definitely the case. It's like there's this whole, you know, problem about how, you know, so how I'm thinking about using a hierarchical reinforcement learning. So how do we formulate that? How do we do design of the reward function? How do we develop a Bayesian algorithm that'll be stable and autonomous enough to run autonomously? So there'll be different students that'll be interested in different aspects of this, and they'll spend more time on each. You know, so like right now I have a very theoretical student in statistics who's looking at some really interesting ideas that came out of DeepMind and that are used in deep learning, which I never do because our areas are too noisy. I would never use deep learning, but they have some great ideas, and they might be really useful in my world in order to enhance autonomy of the Bayesian algorithm. And so there's some really interesting ideas that came out of that area. And she's looking, you know, what can we say theoretically about these approximations? Do they, you know, what kind of posterior are we actually getting? Posterior of what? And because if we can get that straight, then I'll feel much more comfortable using that next year in that trial.
Yeah. And so at that point, you probably have some sketch for a proof, a mathematical proof, but you might, I mean, next step would be to run some kind of a simulation, I guess.
So she's working on the proof. You know, we have proofs in little simple cases, but they're not the real case. So she's working on the proofs, and she'll work on the simulations to see, like, if because we know that all this, whatever assumptions we make, they're going to get violated. And so to what extent can whatever method we develop be robust to those violations? And this is the choice of the violations that really comes from being embedded in the domain science. I mean, I know about the kinds of violations and the degree of the violations and the signal to noise ratio because our team is so embedded in the domain science. I mean, if I was still, you know, a straight up statistician where I was doing mainly theoretical work, I'd just have signal to noise ratios of 2 or something, and I'd get these great results, and none of that's applicable in the behavioral sciences. I mean, unless they're heavily confounded effects. But any unconfounded effects probably are not standardized and equal to 2.
No, exactly. I mean, so how much would you say the quality of ideas that the lab, you know, on aggregates is working on is very important for the success of the lab and the team itself. So how much do you, come up with those gold ideas versus letting, you know, students and postdocs come up with their own ideas? This postdocs come up, like they come from such different fields. Like I have a postdoc in electrical engineering right now. This guy comes up with ideas. I don't even think like him. I can't even, you know what I mean? So it's great. And some of the CS students will come up with ideas that are very algorithmic. And I just, you know, they would never even enter my pea-sized brain. You know, so it's very much a mutual kind of thing. Of course, as the student becomes more and more independent, or the postdoc becomes more and more independent, I understand less and less of what's going on. And they have to keep telling me, oh no, Susan, you're wrong.
this is the way it is, or like, you think that's wrong, but in fact, you're the one that's right. So at first it's more me saying, oh, I think, there's some confusion here. We need to think more clearly, and I correct them. But as time goes on, the whole role gets flipped.
Right. And so okay, this is fascinating. How much would you involve collaborators to make sure, that's, say, these postdocs have the right mentorship versus also the idea itself, is checked by more of a senior person in CS or electrical engineering?
Yeah. So right now I have 3 of my graduate students. Oh, they're all in CS. It just so happens. That's just a fluke. They're all at Michigan right now. Okay. Visiting a collaborator's lab, brainstorming, because we have a study. It's totally different from the one I mentioned earlier. This is an addiction with cannabis use, extreme cannabis use. It's starting to interfere with people's lives. It's to run a digital intervention, and we'll have an RL algorithm in it. And 2 of the students are there acting as mentors because they've already done this in a different study, and they interacted with software engineers and behavioral scientists. And then the target student is a younger student who he's going to become interact with the software engineer at Michigan. Oh. And so they're acting as mentors they're helping the new student and the software engineer learn how to communicate with each other, because these other 2 students went through it already. Yeah. And right. I can't provide that kind of mentorship. I'm not the one that directly talks to well, that's not always true, but for the most part, it's a student working with software engineers. So they're the ones that really get that expertise. So 2 of the students are sent there as experts. 1 student is sent as non-expert. And while they're there, they're also meeting with the behavioral science team involved in this cannabis project.
Wow. Okay. And so these collaborators would join the lab meetings as well? Like, they would be active members of the lab, or they more like, they join when they needed? And so how much do you actually attach senior researchers collaborating with you at the lab?
Yeah, it really depends on the students' interests. But like when I was at Michigan, some of my research scientists were behavioral scientists. They weren't statisticians. So you really had this mix. So now that I'm here, like today, I'll go to a brainstorming session, but it'll be at Michigan. It's in a behavioral science lab. And that's where my 3 students are. And they're going to be presenting all the problems, the issue. How are they going to start thinking about, this coordination so that we can go into the field? We're supposed to go in the field with this algorithm in January or February. And, what are the steps? What are the challenges? There's always a lot of engineering challenges, but there's also a lot of statistical challenges, so that'll come up. And this is a behavioral science lab that it's going to happen in.
That's fantastic. And so for the mentoring, for the day-to-day mentoring of these postdocs and PhDs that do work with collaborators, like you just told us, how often do you meet them, like, one-on-one? Like, it sounds like if we would do that, that would probably be a lot of time.
Kills me. Yeah. I pretty much every day starting around. So today is unusual because you're in Sweden, I had to take some of my morning, right? Yeah. But normally I don't start meeting people till around noon. And then I pretty much am in meetings till like 6:30 or so.
So from lunch, maybe you'll have lunch with them, and then you'll be in meetings basically.
Well, I get to eat lunch on my keyboard, but and I'll answering email while I'm eating lunch on my keyboard. But there's meetings, I know a lot of CS people, for example, who are much better at, I'm a statistician. I never grew up running a lab, so I'm not doing the best job. Do you know what I mean? I'm not someone you want to emulate. Like, so this is part of me trying to learn. Like I share lab space with with a computer scientist, and the way she runs her lab is so much more efficient than me. It's just unreal.
So what's it like? Tell us what you know briefly about that setup. Like, why is that better than yours? Like,
it just is
very good.
It's just that she has a much more natural hierarchy of students. So there's enormous mentoring within her lab, between students. I'm trying to create that same sort of mentoring structure.
Yeah.
Where older students, postdocs mentor older students, mentor newer students. So she has that. We have they hold a little seminar series. Our lab's involved in that to the extent people want to get involved. They do. So when they want to meet with her, there, for example, in this particular case, there is a web site you go to and you see these 30-minute slots and you sign up for a 30-minute slot. And you have to, if you sign up for a 30-minute slot, you have to have your act together so you can communicate well in 30 minutes precisely.
Yeah.
And I don't know about you, but it's very hard for me to have my act together at that level. And so like I'll have slots where people talk to me for an hour, and it's because I am just not as together. It's hard for me.
Yeah, well, I mean, it's part of a it depends sort of on the setup of the team and also the culture that you want to create. I mean, it sounds like more of your lab sort of like a startup type of thing where they invite everyone. Is like, there's not so much hierarchy. Basically, everyone can contribute and so, but it's also a bit more unstructured and it gets
right.
Messy. But yeah, and that probably has an advantage as well compared to a more sort of structured lab setting. But it's more efficient in terms of, knowing where to, go if I'm a student and I need some help.
Yeah,
right?
The more structured setting is more efficient.
Yeah.
She does all kinds of really innovative stuff. All kinds of, like there's a peer pairing we participate. So every week you're a student in the lab, postdoc student, whatever, in the lab, and you have an appointment with someone else, a random person in the lab for 30 minutes where you're supposed to meet with them and you talk about research. So every week you have some random person you're supposed to meet and talk about research. This is fantastic.
That's fantastic.
I would have never thought about something like this.
But this is like, must be some kind of a lab assistant somehow, because I'm just thinking about the time to arrange these things, right?
That's a senior. Yeah, so that's why you need either research scientists like I had at Michigan, or you need people who have something like a teaching position that get involved.
Oh yeah, I see.
They're doing some research, but they're doing some teaching, and they'll manage a lot of this. So you need people who are research scientists, whether or not their title is research scientist is totally different.
Yeah. Because I mean, the administrative part of this, of organizing, it's humongous. I mean, just so hard, like in terms of emailing and just getting. So do you have sort of a lab assistant or?
Yeah, I do.
Okay. And so the lab assistant will block off time, organize meetings, and it's usually or what's like, it's a dedicated.
No, she organizes the big lab meetings, and she does enormous amount of work because of all the grant work. That's an enormous amount of work. Okay. And I don't do, she does all the budgeting, making sure students are being paid appropriately.
I see.
It's an enormous amount of work. And she also tutors people. The person who works with me, she has an English background, so she helps people in writing. This is very
fantastic. Yeah.
We're really lucky. But in general, most statisticians wouldn't have this. I just accidentally have this because I was in this research environment at Michigan, and I had somebody like that for years because of the way I get. It has to do with the funding mechanism. There's a price for everything. Nothing is free. It's there's a price for this. It's not like, I mean, if I think of my former self, I don't think I would have wanted to pay the price I pay for this. So, it's not like, oh, I wish I had a lab assistant. No. There's a price. Everything has a price.
Yeah. And you mean the price now is that you actually need a research lab, assistant to make sure things are actually running. Otherwise,
and the price is I have to be bringing in enough funding to support all of these individuals. And it just so happens that bringing in funding aligns completely with my goals in terms of impact. Now, if it did not align Like I would want to bring in funding no matter what, because it aligns completely with my goals, my research goals. But if you're the kind of person who's more interested in foundations of data science, this is not going to align with your goals at all. And you don't want then you don't want an administrative, you don't want to pay that. You gotta, it's, yeah, there's a price for everything, has its pros and cons.
I see. And this is, I mean, your goal here, Susan, to repeat that, it's really like, what's that goal? Like, why are you doing this? What's
in my life, what my goal is right now?
Yeah.
My goal is to have an impact on real life, in which we have real life online statistical algorithms that are part of interventions. They're processing data, they're autonomous. Really, it's an AI type goal. It's processing data. This is not batch data anymore. This is not, I get a batch data analysis and I can rerun my statistical analysis. Or no. In real time, every night the data gets processed, and that determines how decisions are made the following day. And I want to see, to what extent can we really improve from a domain science perspective, can we improve people's lives, provide helpful support to them as they go about their life? They struggle with addictions, mental illnesses, managing cardiovascular diseases. Can we really impact them? Can we really help them out? And can I do this through these statistical algorithms? That's what I want to do right now. That's all I want to do. That's pretty much all I want to do.
That's fantastic. And so if someone wanted to join you or take inspiration from your path, Susan, in terms of building, mastery in statistics, computer science, basically a hybrid of you, basically an evolved version where you leave the baton to someone, coming in, what would you say to them? Like, what's that, what should they, what kind of skills should they build? Where should they go?
Take a lot of probability and statistics. Like this electrical engineering postdoc I have, he's going to go to Cornell Tech. I think he's going to do something very similar. And this guy is very mathematical, very theoretical. I love theory, man. I think theory is the place to start. Probability, man.
More probability. Exactly.
Yes. Everybody needs probability and theoretical statistics.
I mean, I love probability as well. It's just not enough time to build that, like go even further down the rabbit hole. More
you have to do that in undergrad and grad school, right?
Yeah,
you got to do it early.
It is definitely harder, as where we stand. But for me, for example, as a social, people like me, computational social scientists, they sort of discover this maybe later. Especially those that started, and a couple of years ago, and getting into this, sort of you realize you need to build these skills. So then you need to do it, nevertheless.
Hard.
So Susan, we are very much at the end of our conversation. I wish we can go on for so much longer. I had so many questions for you, but this was, really sort of the lab focus was critical.
Yeah.
Even there, I had a bunch of other questions related to collaboration and managing, takers and givers and stuff like that. But perhaps we'll save that for another time, because I know that you need to run very soon. But Susan, so basically, as an ending challenge here, if a challenge or a question that you want to give for the listeners listening to this video, this interview with you, what would you wish them to do more of, less of? Where would you want to see them if you meet them a year from now, maybe 5 years from now? What would you want to see them do?
I think my challenge is that we as a field, I'm thinking of we in statistics, we need to be more supportive of statistics. We need to be supportive of young people who are doing statistics. Let's not eat our young. So like if you're in a review type setting, remember, you want to help the statisticians. It's, there's only so many resources going around. And if we don't take care of ourselves, someone else is going to get those resources. And in my opinion, we're the people to get it.
Thank you very much, Susan, for
Thank
this
you.
excellent interview. I hope that we'll see you in the future, and I will definitely be in touch with your algorithm somehow in some mobile phone application. It will be popping up.
Okay, you take care.
Thank you very much.
Bye.